Okay, so let's kind of go ahead and write up what we've been practicing with solving two-step equations the past few days. So you can go ahead and click, um, and we'll save to keep. Get our pen, and then let's do it. So first problem we had was negative 9x minus 35 equals 10. So we started off when we were doing these problems with visualizing it by using the arrows in the boxes. So we're starting off with what does happens to x first? Well, it's sitting next to negative 9. So that would be times a negative 9. And then let's make this a little thicker so you can see it better. Times negative 9. And then we subtract 35. And we got 10. So when I fix it, I'm keeping my 35, but now I need to add it. So 10 plus 35 is 45. And then this was times negative 9, so I keep my negative 9. But now I have to divide. And 45 divided by negative 9 would be negative 5. So of course I want to check if I got the right answer. So I start off by writing out the problem. Negative 9x minus 35 equals 10. Then I'm going to do negative 9 times, I think it's negative 5 minus 35 and see if that's 10. So getting my candy dandy calculator here. Negative 9 times negative 5 minus 35. And it says 10. And it was supposed to say 10. So I got it right. Then we kind of made the connection to how do I show the algebra? So we would start with exactly the same problem. When I do the algebra work, though, I'm not going to do what goes across the top of the arrows. I have to do that thinking in my head. And I'm just going to end up writing eventually the stuff that goes along the bottom. So when we're solving equations, we kind of go backwards and we do the opposite, right? So that's kind of how we ended up on the right and went to left, which is backwards of how we usually read things, right? And then we were taking the operations and turning them opposite. So for this one, I like to start when I draw kind of a line down where the equals was, just so that I can kind of keep track of what happens on both sides. So what's happening to x? We're multiplying by negative 9, subtracting 35. So subtract 35 is the first thing I have to fix. And I fix subtract 35 by its opposite, which is add 35. And add 35. Oops. Let's go ahead and erase that so you could read that better. Like this. And so these go away, right? Because negative 35 plus 35 is 0. And 0 plus anything is itself. So I still have negative 9x. And it equals 45. Then I need to divide by negative 9. And I get that x equals negative 5. So you can see there that both of the problems, or both ways we did it, got us to x is negative 5. And then if I was just doing it starting with the algebra, I could do the check just like we did at the beginning. So second problem, same kind of idea. When I do the boxes, I'm going to look at what's happening with x. So x is still sitting next to a number, and it looks like it's a 4. But actually, remember, we always look to the left to see what sign it is. So it's not just a 4, it's a negative 4. So the first thing I would write up there is times negative 4. Then we have this 6 here. The negative is on the 4, right? That's like the negative or subtracting. The 6 is a positive 6, so I'm going to put plus 6 on this arrow, and it was negative 30. So to fix it then, instead of plus 6, I got to subtract 6. Negative 30 minus 6 is negative 36. Then I keep my negative 4, and I have to divide by negative 4, and I get a positive 9. Let's check, make sure I got it. So 6 minus 4x equals negative 30. 6 minus 4 times, we think it's 9, is that negative 30? So let's put that in my calculator. 6 times 4, oops, I pressed that wrong. 6 minus 4 times 9, and it says negative 30, and it was supposed to say negative 30, so I did that right. If I look at it with the algebra, same kind of idea. I have 6 minus 4x equals negative 30. So I'm doing the across the top of the boxes thing in my head. X is multiplied by negative 4. Then there's this positive 6. So to fix the positive 6, I have to subtract 6 and subtract 6. Those go away. And I have negative 4x. Don't lose your negative, right? It's still there. We didn't get rid of it. And then negative 30 minus 6 was negative 36. And then there's multiply, so I got to divide. And I get that x equals 9. And again, I could check, but I already did that, so I know that 9 is the answer. So the idea when we go algebraically is that what we did in the box is we kind of do some of that thinking in our head and then write out what's happening. Because eventually when you get to a check and it doesn't work out like this did here, once you have the work written out and you can see it, it's much easier to figure out what went wrong. So that's really the value of doing the work here, is to be able to fix it if something was incorrect. So I'll go ahead, go back here. We'll go into our math notebook and add this in. And here we go, two-step equations.